Welcome. In this lesson, I want you to take the moment right now and write down these two special right triangles, the 45-45 right triangle and the 30-60 right triangle. Using these two triangles, no calculator necessary, you're going to be able to do this lesson and the next. To take the sine of 45, you go to the 45 right triangle. Sine, remember, is opposite over hypotenuse. So that's just 1 over the square root of 2, because the opposite of 45 is 1. The hypotenuse is the square root of 2. And then make sure you rationalize your denominator. Multiply by 1, meaning the square root of 2 over the square root of 2, so we don't have any square roots in the denominator. And your final solution will be the square root of 2, which it allows you to put that in, over... Well, that was really nice. I guess do that fraction first. Square root of 2 over 2. I can't get in there now. What happened? I want to get back in there. Oh, there we go. And there's our answer. And as you move forward, tangent of 60, I'm going to go to the 60-degree angle. Tangent's opposite over adjacent. Here's the tangent. Be careful. Tangent's up here. So opposite's the square root of 3 over adjacent. That's 1. Square root of 3 over 1 is just the square root of 3. And you're done. All of these will be that simple. So if you haven't written those down, you might want to rewind and write those down. Tangent of 45 is going to be 1 over the square root of 2, but then you rationalize the denominator and you get the square root of 2 over... Oh no, tangent's 1 over 1, right? Again, that's why you write them down very quickly. Write down that 45. It's 1 square root of 2, and I'm asking for the tangent of 45. Tangent is opposite over adjacent, 1 over 1. So my answer is just 1. 1. Again, let's make sure we write those two special triangles down in terms of radians. I've written them both down here in terms of radian. I didn't put this angle measure here because it's the same as pi fourths. It's a 45-45 right triangle. Pi fourths is 45 degrees. Pi sixths is the 30 degrees. Pi thirds is the 60 degrees, because the ratios will be the same regardless of what unit we measure it in. So when we do the cosine of pi sixths, that's the same in the cosine of 30. Cosine is adjacent over hypotenuse. Adjacent is square root of 3. Hypotenuse is 2. So my answer would be a fraction of the square root of 3 over 2. Again, sine of pi thirds. Pi thirds up here. Sine is opposite over hypotenuse. So it's just like the last one. Opposite square root of 3, because pi thirds is up here. Opposite square root of 3 over hypotenuse, 2. So again, square root of 3 over 2. And if you have those triangles written down, you'll fly through this. Cosine of pi thirds, cosine, here's pi thirds, cosine's adjacent, which is the side next to pi thirds, over the hypotenuse. It's just 1/2. 1/2. If you have any questions on how to do this, please do bring your questions to class and I will help you. This one, by the way, is the square root of 2 over 2. And the reason it's that is because sine of pi fourths is sine of 45, 1 over the square root of 2, but then I had to rationalize. Did that disappear, or did I not write the square root of 2 there? That should be a square root of 2, and that should be a 1. 1 square root of 2.